Okay, so we're looking at Chapter 2, Section 6, and we're going to do a sort of a brief flyover of the periodic table, but there's a lot of information here, so get your worksheet out, get your notes out, and I think you should look at your book too. So first of all, we're going to find that we can extract tons and tons of information from the periodic table. And the periodic table is a tool that you're going to have with you on every graded exam, and really every chemist always has access to a periodic table, so it becomes a tool that you want to be used to, and you want to have some great facility with it. So it turns out that the periodic table was developed by a guy named Dmitry Mendeleev, and I'm looking at TRO on page 57, and it turns out that Dmitry Mendeleev found that if he lined up the known elements in order of mass, he found there were regular patterns that came out. In other words, as you've got pointed out here, lithium and sodium and potassium, they all acted in similar fashion. They had similar chemistries. And helium and neon and argon had similar chemistries, and beryllium and magnesium and calcium had similar chemistries. So he said to himself, you know what, if we lay these out on top of each other, we can make a periodic table. That's exactly what he did. So the periodic table is a table that's going to help you predict things just based upon where particular atoms or elements are. So lithium and sodium, they act the same, and potassium acts similarly. Okay, these three act the same. These two have similar properties. Boron and aluminum have similar properties, and so on. So this is a simple periodic table. It turns out that I think there were 55. Tro probably says I think there were 55 elements that were known to Dmitry Mendeleev, and that was in the 1800s, late 1800s. Is that right? In the late 1800s, and so he was just able to map out these properties. He was a chemistry professor, and it was very, very clever thing he did. Super useful to us. He was also able, of course, to predict the existence of other elements or the properties of elements based upon where their mass was supposed to be. For example, he predicted an element here called, I think, Eka-silicon. It's in your book. If I'm getting that right, if I'm getting that wrong, please don't say anything about that in the comments. Just, there was an element. I think it was Eka-silicon. He called it right here. And it turns out that he said, well, if there is such an element called Eka-silicon, then it's probably going to act or have similar chemistries to carbon and silicon. In fact, it did. And it was discovered by a German chemist named Clemens Winkler. He named it germanium. So if you look in the periodic table, you'll see a germanium there. So all right, that's how the periodic table started. Let's look at a couple periodic tables with a little more detail in them. So you want to get your eyes used to this now. The metals, everything, can you see a dark solid line coming across here? Okay, so everything on this side besides helium, or rather besides hydrogen, everything, everything on this side of that line is a metal, and everything on this side is a non-metal. Excuse me, please. I say everything, but of course you can see things that are actually on the border are called metalloids. Can you see that? So these are all metals over here. Can you see that the vast majority of the periodic table is made out of metals? Okay. So the vast majority is made out of metals. There's a bunch of non-metals over here and one here. And then there's some things across that line right there that are metalloids. In other words, they've got properties that are similar to metals, but not exactly, not completely. Sort of in the middle. Okay, another way to look at this periodic table is to think about main group elements and transition elements. So these guys over here are a main group element. This is called the S block, and these are main group elements. This is called a P block, and these are called transition elements. The reason they're called transition elements is likely because their properties are very difficult to predict. So these elements over here sort of all act the same. Or, the ones in this column act the same, the ones in this column have similar properties. The ones in this column have similar properties, and these have similar. So the main group elements are very predictable, or I should say relative to the ones that are not in the main group elements. So you've got main group elements over here, main group elements over here. The group number, as you can see, is 2A, or 2. The group over here is 1, or 1A. The group over here is 3A, or 13. 4A or 14. Okay, both of these are two different ways to name this group. All right, so that's a quick flyover of the periodic tables. In the elements in the periodic tables, let's look at something that we can get. Let's look at some predictions we can make based upon the periodic tables. What ions are common in nature? So a main group metal tends to lose electrons, forming a cation with the same number of electrons as the nearest noble gas. Let's go back to this last slide here now. A main group metal, okay? So you know these are all metals, right? These are all metals. So a main group metal, either here or here, has a tendency to lose electrons and then take on the properties of the closest noble gas, nearest noble gas. So let's look at that. If you take sodium, sodium's got 11 protons. So a sodium atom's going to have how many electrons? 11. And what ion is sodium likely going to present in nature as? It's going to lose an electron. It's going to go with 10 electrons, and it's going to, in the noble gas that has 10 electrons looks like that, right? So it's going to end up looking like neon. Okay. Forming a cation with the same number of electrons as the nearest noble gas. A main group nonmetal tends to gain electrons, forming an anion with the same number of electrons as the nearest noble gas. So here's a main group nonmetal. Let's look at this one here. Fluorine. Fluorine has a tendency to gain electrons to give it the same number of electrons as the nearest noble gas. So that's going to have a tendency, it's got 9. It's going to have a tendency to gain an electron, in other words, make 1. And that will make it F minus, which we call fluoride, and it will have the same number of electrons as the nearest noble gas, which is neon. Okay, so again, a main group metal tends to lose electrons. A main group nonmetal tends to gain electrons, forming cation and anion, respectively. Okay, and then finally, let's say, what are some elements with predictable charges? Okay, this is something that I think you might memorize. I think it's here on page 60. This is on page 60, but it also shows up, I think, on page 88 or 89 with a little more detail in it. Look at this, ions, the elements that form ions with predictable charges. So as I said, fluorine was going to be likely to pick up an electron, right, to be neon, which is here, or to have a same number of electrons as neon, which is here. Oxygen's going to pick up 2, right, 1, 2, to make it the same number of electrons as neon. Nitrogen's going to have a tendency to pick up 3, right, 1, 1, and if it picked up 1, it would be like oxygen. If it picks up 2, it would be like fluorine. If it picks up 3, it's going to have the same number of electrons as neon. Sulfur is going to have a tendency to pick up 2 to make it like argon. Okay. By the way, can you see a trend here? 1 minus, 2 minuses, and 3 minus. By the way, phosphorus, which is right here, also has a tendency to take on a minus 3, but it has other ways it can present in nature as well. So we won't say it's predictable. We'll say it's, your first guess would be 3 minus. But there's other possibilities for phosphorus. Okay, now aluminum's going to have a tendency to lose 3, right? Because it's a main group metal, so it's going to lose electrons, and it's going to end up being like magnesium, sodium, neon, which is right here. Okay, so that has a predictable charge of +3. Look at this. Notice these all have a predictable charge of +1. These all have a predictable charge of +2, besides beryllium. Okay? Can you see that? Okay, so let me look back at the worksheet. A main group metal tends to lose electrons. We got that, okay? A main group nonmetal tends to gain electrons. We got that. And predict the charge of the monatomic ion formed by oxygen. I'm not going to tell you what it is, but I'm hoping that from what we described earlier, that would be something that you get. Okay, hope that's helpful.